Hi there, welcome to the channel. I'm Mrs. R. Let's do some math. Today we're going to do 3 examples of 2-step inequalities. Now the instructions are the same as when we did 1-step inequalities. We're going to solve the inequality and then graph the solution. But there is one very important thing that we kind of worked through and explained the reason why in our 1-step inequality video. But this rule for solving inequalities, remember, is that anytime you multiply or divide by a negative number on both sides, anytime that's one of your solving steps, you have to flip the inequality sign. So we're going to do 3 examples. We'll solve the inequality, graph the solution, and then move right on. So we have m over 3 minus 3 less than or equal to negative 6. Now, there are 2 different steps you could take first. You could handle the minus 3, or you could handle the divide by 3. I think most people would probably do the add 3 first, so that's what I'm going to do. Plus 3 gives us m over 3 being less than or equal to negative 6 plus 3 would be negative 3. Now, since this says m divided by 3, I'm going to use multiplication, that inverse operation. Our 3's will cancel to 1, leaving us with m on the left-hand side. And then negative 3 times 3, negative 9. So there's our solution. We have found our solution. Now we need to graph it. Negative 9 would be right here in the middle. We do have the or equal to part here, so we are going to do a solid circle. And then I want the m's that are less than or equal to negative 9, so we'll shade to the left. For our second example, here we have negative 3 times the quantity p minus 7 being greater than or equal to 21. Now, the first thing that most people would do, well, I don't know, I'd say it's about half and half split. You can either divide both sides by negative 3. Remember, we've got that rule, the flip the inequality rule, if we do that. The other thing you could do is actually distribute the negative 3. More of a simplifying step on the left rather than a solving step on both sides, but both are perfectly valid options. We're going to actually do both. So you see that you do get to the same number as long as you follow that flip the inequality rule. We're going to flip the inequality on the right-hand side. So on the left, on the distribution method, so we'll distribute in negative 3 times p. Then negative 3 times negative 7 is positive 21. Then I like to subtract the 21. So that does end up canceling on both sides. So it leaves us with a 3p on the left, and then we're greater than or equal to 0. Since everything on that side did cancel, we end up at 0. Then technically we're going to divide by negative 3, which, oh, look what came up again. We're dividing by negative, so we're going to have to flip that inequality. The way to avoid this, if you wanted to avoid this, would be to actually add 3p to both sides for a second. It does add an extra step, and you still have a 0. It doesn't really help that. But then when you divide, we get our 3's canceling, and then we just have 0 is greater than or equal to p. So that should be our answer. Now let's see if we get the same thing over here, starting with the division method. So if we divide by negative 3, and on this side we are accepting that we're going to use that rule of flipping the inequality. So we have p minus 7 on the left. We're going to flip the inequality. And then 21 divided by negative 3 is negative 7. Then to use the inverse operations, we'll add 7 to both sides. Of course, it cancels on the left. That was why we chose to add 7. But then on the right, it's going to cancel also, leaving us with 0. Now, if you look, One of them says that p is less than or equal to 0. It's the one I just boxed. The other one says that 0 is greater than or equal to p, and those are the same thing. So a little smiley there. Now we just have to graph our solution. So we'll mark the 0 with a solid circle because it does say or equal to. And we want all the p's to be less than 0, or we want 0 to be the biggest number of everything, whichever one you're looking at. They both would interpret to shade to the left. All right, and then our last example. We have the quantity negative 11 plus n divided by 15. And that is less than negative 1. Now, anytime I see a fraction, especially if the entire side is a fraction, I'm going to multiply by whatever the denominator is. That will cancel out the fraction, and then I don't have to worry about fractions anymore. Then on the right-hand side, negative 1 times 15 is negative 15. And then I have a negative 11 that's adding to n. Now, since it's negative 11, I could add 11, and then those will cancel to 0. And n is now less than negative 4. So this one didn't have any tricks. Nothing crazy weird about that one. It just started with a fraction, which kind of freaks people out sometimes. Now this does say strictly less than. There's no equal to, so we're going to use an open circle. And then we want the n's to be less than negative 4, so we'll shade to the left. And there you have it. Basically, you solve the same way you solve your one-step equations, but then you apply those inequality rules. Don't forget, anytime you multiply or divide by a negative, you'll need to flip the inequality. But other than that, just follow your equation patterns and then just graph it the way that's appropriate. So thank you for watching this video on two-step inequalities. If you found this video helpful, please hit that like button because that'll help our videos spread to more people. And if you have any questions or there's another concept that you'd like to see us make a video of, just leave a comment and we'll try to get that done as soon as we can for you. But that's it for me. I'm Mrs. R, and this has been me doing math. Catch you guys next time.